Hey everyone, it is Mr. Simons. We are going to look at rate of change in this video. This is the first video for lesson 3 in chapter 3, and rate of change is something that a lot of you are already familiar with, and you may not be aware you're familiar with it. So what I want to do is introduce it in this video, give you a couple real-world examples of it, and then look at kind of how we might find it. So I want you to think about when you're in the car and you're driving. Okay, and you're on your way to school. Your parents are probably driving you, and you look at the sign on the road, and you look at the speedometer in your car, and hopefully your parents are driving the speed limit, although I know how difficult that can be at times, and maybe they are going 25 miles per hour. All right, so what that means, and if you intuit this and think about miles per hour. It means they drive 25 miles in 1 hour. And if you're driving 25 miles per hour, that means like in 2 hours you would drive 50 miles. In 2 hours you could drive 75 miles in 3 hours, right? So if you're driving at a constant rate, that's what that means, and this would be your rate. Your rate would be 25. It means every hour you can drive 25 miles. So if you think about that in terms of on a graph, about what that would look like, right? And think about independent and dependent variables. Our independent is always the thing that we can control, and then the dependent is the thing that comes as a result of that. So in this case, the thing you can control is how long you drive, right? Because you can decide that, hey, I've driven long enough, I'm going to stop. All right, so your time would be your dependent, and that would be your x. And in this case, it would be hours. And then the distance you drive would be your y, and in this case, it's miles. And that's how you find your rate. And now if you look at this, it's miles per hour. And if you look at 50 and 2, well, if you take 50 and divide it by 2, it's 25, which gives you your rate again. If you take 75 and divide it by 3, it also gives you 25, which is your rate. So it's always a y over x relationship going on here. And that's important because we're going to use that with slope. All right, so I just kind of want to introduce, move forward with that. All right, so let's look at here, this real world example. Use the table, change, then explain its meaning. The one thing we do know now, just from that little talk we had, is y over x. It's a ratio of y over x is the rate of what we're going to find. It's the dependent variable divided by the independent. And here they're telling us what the dependent and independents are. The total cost, this, depends upon the number of computer games. All right. So it tells us already a little bit about what this means. In order to find the rate of change, all you got to do is let's look at the increments and how this goes up. So on your x, right, and I'm going to color code this, your x, it goes up 2 every time. Okay, so that would be your x, it goes up 2, and then your y, I'm going to use another color, use purple. It looks like it's going up 78 each time. So 156 minus 78 gives you 78. And 234 minus 156 also gives you 78. So your y over your x. Okay, so if we were to put that in terms of using the numbers and find the rate, well, we know it's a ratio, right? So for my first one, for this one right here, it's going to be 78 divided by 2. All right, which is going to give us 39. And then for the next one, well, I really don't need to do that one because it's the same, right? It's 78 over 2 again, which gives us 39 as well. So it's the same rate for each time, and we'll talk about what that means in a second. And so now it says explain its meaning, right? We found the rate. The rate is 39, and it's y over x, so it's dollars over games, right? So it's $39 per game. And we wouldn't really write it that way. We would go 39 per game. And if you explain its meaning, well, all that means is that each game costs $39. And It's that simple. Just like in the early example I used, every hour you can drive 25 miles. That's what the rate means. All right, let's look at this one right here. It says determine whether each function is linear. Well, linear function is a function that when you graph it makes a straight line, right? So we're going to go with that, and in order for that to happen, all these rates that we come up with, just like we did in the last video, or the last example, have to be the same. They have to be the same, otherwise you're going to get something that looks like, you know, this, and while it's cool looking, it's definitely not linear, right? It does not make a line. So in order for it to be a linear example, you have to have, it has to make a straight line, and your rates all need to be the same. So all you do for these is you just compare your rates. You figure out what they are, and you compare them. So on my X for letter A, it looks like that each of them goes up 3. I'm just going to write that in. And for my Y, it looks like the first set, it goes down 2, goes down 2, goes down 2, goes down 2. And so for my Y over X, for my first one, right, for this one, I get negative 2 over 3. All right, good. For my next one, I get negative 2 over 3. And then you can see, as you continue to go, you get the same thing each time. It's constant. It's a constant rate of change. Constant means stays the same. So yeah, this one's linear. This would make a graph similar to that. Now for B, it's going up 2 again, but this time on the X. And it goes up 2 each time. All right, that's good. That would be my X. And then my Y, it looks like it goes up 2, and it goes up 4, and it goes up 2, and then it goes up 4. So there's some kind of pattern, but I don't know if I have a constant rate of change until I think about it in terms of, is each of these the same? Well, this first one, you have 2 over 2, which is equal to 1, right? My next one, I have 4 over 2, which is equal to 2. And so right away, I know that 2 and 1 are not the same. And I know that I don't have a constant rate of change. And you can see that this one's going to be the same as your first one, and then this fourth one's going to be the same as your second one. So while there is a pattern, it's not a linear pattern. It's not constant. And the linear pattern has to be even Steven the whole time. It's got to work out. All right, next video we will start talking about slope.